Alright, coming online. Yeah. Turn up my volume. Check my stream sound. Yep, stream sound sounds good. Alright, I'm gonna switch it to the camera view. It's gonna look wonky because I don't think my lights are dialed in. Yeah, those are not. Those are not dialed in. That is so my camera does some. My camera does some dynamic adjustments. I don't know if I want that. Well, this isn't too bad, right? My camera dialed in. Looks like I do have some glare on my glasses. Let's pull up a big white screen like this Intel. That's not too bad. All right. Let's see what happens if I'm like. So my camera's gonna automatically be adjusting for stuff. I don't know how I feel, but that's that's too dark. OBS is over there, so I'm like looking at it, trying to see what it looks like. Let's see if I switch the light to like more of a white. I have to like look at the stream to see what the lights look like. How does it look on stream? All right. Well, I have to like look at it after. Hopefully this doesn't look too bad. Probably there's huge lights right in my glasses. That's what I'm concerned of. Maybe if I look like to the side really fast, like no, didn't catch it. All right. Yeah, there's big glaring. Oh, there they are, but not so bad here. Maybe if I tilt up just a little bit. Maybe I need to move those higher. Anyway, we'll look at it after. All right, so oh, I'm live. Yep. Let's close that. Close that. I was having some Elgato technical difficulties. I think I don't want the camera to be adjusting. I think is the problem I have now. Like if I move, this is turning into a stream setup. Stream setup stream. Enhance lighting. What does that do? Uh-oh, that freezes my camera. Boo. Yeah, that's a really good capture right there. Okay. Turn that off. Turn that off. Oh no. No, I lost my camera. I'm frozen. This is why you shouldn't have a stream about setting up a stream. All right. No. This is bad. Oh, am I back? There I am. Wait, okay. Just light, adjust. Oh, it has backlight compensation. So we just turn that down. And turn off the auto light white balance. Oh, wow. So the camera was doing something. What does this do? Makes it look awful. Okay, let's turn that auto white balance back on. I'm just trying to get something here. That looks horrible. Why isn't it adjusting? Okay, so let's turn some of this brightness down. Turn some of this brightness up. Doesn't look too bad. Right? All right. Let's stop fiddling with that. Okay. Let's look at some code. All right. Last night we left off with taking a sip of. This is Gamer Fuel. This is just LaCroix Gamer Fuel. I feel like. Yeah, I think I need to turn off the auto white balancing stuff. And yeah. Anyway, that's another day. All right. Yesterday we left off. Blah, blah, blah. How does that look over there? Just checking my streaming computer here. Not too bad. Okay. Yesterday we left off with I had an implementation. I think it was this one where if we look at the console, yeah. This one was giving us a wrong answer. Oh wait, no, that is giving us a wrong answer. Let's see, well, let's go to the code here. Yeah. So in yesterday's stream, it kind of ended with like we were getting a result that didn't make sense, and it was like we kind of figured out, oh, it's just like with this L in this one spot. But then what I figured out is like because of how the algorithm is running, like it does the first 16 characters, loops over every string, and then it goes and if there's more characters, like 16 more characters, it does the second 16 characters. And I figured out that instead of doing a cumulative add inside this loop, I needed to do an OR with I needed to just do an OR, which is cool, but that breaks down when you do the first 16 characters, and then you do the second 16 characters. Well, it's possible that like in the first 16 characters, you get a 1 at the 5th element, and then in the second loop, you also get a 1 in the 5th element. And then because you do an OR, you lose that. Like, it's 1 and 1. It's 1 or 1, and so you get 1. So then you end up losing a count. And that's exactly what was happening. So to fix that, I created this inner result. And what that one does is, yeah, it's doing the OR, but then once you get out of this loop, which means you finish processing a batch of 16 characters, you go ahead and do the cumulative add here, because that is what we want at this point, and then you reset the inner result. Yeah. So I added that. And once I added that, it worked. Like, I think that was this solution right here. Yeah, I added that. And in fact, it was cool because the result of this one was that it beats 100%, right? That means we got to the top spot, which is cool because like our first solution was down here in 60. Like, look at the difference between our first submission at 80 with this loop right here at 81 milliseconds. And then we went to this one right here at 23. So that's like a quarter of the time. So that's pretty cool. Unfortunately, when I did subsequent submissions, like it still slowed down. Like, so I think there's an aspect of like leak code itself. It's like what, luck of what computer it runs on or something like that. So it's not purely algorithm driven. But and we even noticed that on the first one where like we did 81 milliseconds and then we got 92 and then we got 46. That's as good as pretty close to this one. So yeah, kind of hard to tell if we actually achieved anything, except for it was cool on this one when I first submitted it the first time and it's like, you beat 100%. I was like, yee. But then this memory thing is a little like, being down on this side of memory. I think on the first solution, we actually did better in the first solution memory wise. Although that's hard to interpret because like we beat 93% in the first one, but then the second one we're down at 24. Doesn't make any, these stats actually don't make any sense, right? So that's a bit disappointing, but yeah. But there's a few things though, like we kind of knew just doing the SIMD wasn't gonna be like, what am I trying to say here? Like, even though we're using SIMD, it doesn't solve the core thing of like the fact that we have a double for loop. So like, this for loop, this next 2 for loops here is going to be what really dominates how this algorithm scales. We can add SIMD so that we're instead of in our first solution, which is here, instead of processing a single character at a time, we can process 16 characters at a time, but you're still having to loop over, you're still having to loop. Well, so this one, so it would be, like this loop count times this loop count, which, this one right here, this virtual, if you pass in 1,000 strings, this is 1,000. I wonder why the less than or equal to the virtual count works, but hey, the algorithm passed, so we won't question it. So if there was a way, which I haven't spent any time thinking about it, but if there was a way to get rid of the double for loop here, that would be the thing that really unlocks some scale. But the journey to solving this has been a lot of fun. First, there was just like figuring out, how do you load a string into a SIMD register, and then figuring out how to do the comparison, and then figuring out how to deal with, which I'm not sure we need this anymore. We actually might not need to do this stuff anymore, right? Because this is where we were kind of like doing a division. We were doing a mask to get the, instead of having a 255 in one of the slots, it's just a 1, which mattered when we were doing an add. So maybe what we need to do is we don't actually need to do this stuff per loop here. But, you know, like I said, at this point, this is kind of like you're going a little into the weeds on optimization. And it's like, oh, moving this one line outside of that loop. Be like, yeah, it will be faster. But like I said, a nested for loop is going to be what really dominates the performance. So it could be interesting implementation wise just to move this stuff out, because I don't think we need it inside this loop. I might do that actually. Yeah. So the other thing about this implementation that we had to figure out was like, okay, we got all this data and in our result, how do we get it out? Like, and so we have to do this aligned allocation to this and basically store our result into that and then loop over it. So this is something that feels a bit clunky in this implementation. So let's go back to the code here. And so one thing I did was I looked up a way to create a struct and get it to be aligned 16. So then I don't have to do that aligned allocation, because like just allocating one of these things is 16 byte aligned because I put this attribute on it. And this is Clang specific. It would be something different if I was using the MSVC compiler. And I actually don't know why I did a union here. That's something I want to try. So first, I want to try a few things. I want to try a few things just to like put a little ribbon around this implementation and call it done. So I want to go just checking out my stream here. Yeah, I want to see. I think I don't need like a union with an anonymous struct inside it. I think I can just be like struct align data, and I can put this stuff on it. And I don't even need this uint64 thing. I can just be like, I need 16 elements because, you know, result has 16 8-bit integers in it. It's just kind of something we've been working with the whole time here. So I don't think we need this bad boy anymore. This anymore. We can take that. Get rid of it. Okay. All right. Don't think I need to do that. And then here, I just need to get a pointer to the first element. And here we can do this. It would be cool to not have to do this loop to add everything else up, but I don't know of a way to do that. Wonder if there'd be, I suspect there'd be a way to do, like, replace what we're doing, you know, from here to here, replace that with, I'm pretty sure there's a way to do this in SIMD. I'm going to have to, like, go ask someone who knows more about this stuff. But anyway, like, this chunk right here, basically, replaces this. Like, we don't have to do this aligned alloc anymore. We just created a struct that is 16 byte aligned. So if we go and build and run this, it should work. And I'm pretty confident because I did this last night after this. Had to end the stream kind of abruptly last night. Yeah, that worked. Okay. So the other thing I want to do is I don't think we need to do this in here. All right. What we want to do is we want to say here we want to say inner result. So that's what that does. And then all right. So with that, we don't need this. We can comment this out. All right. Let's go see if that works. It did. Tight. So we can. All right. So over here on our. All right. So let's see. Let's go over here. And let's cut and paste. Like the good engineers we are. Like I said, this is very specific to Clang. Like if we were doing MSVC or GCC, it would probably be something else. But it's just a way of saying we want this structure, which would probably typically be byte aligned, since it's probably be byte aligned. Well, we're saying we want it to be 16 byte aligned, so that accomplishes what we were accomplishing here. But to do it that way, don't need this. That was just a trial, like kind of like prototyping, figuring it out. So to do that, we have to do this. We just have to pass the data slightly differently. Get the like the pointer to the first element, basically. Last night I was naming things haha because I was just tired and trying to figure out how to get it to work. I hit save because that's cool. All right, and then we figured out that we can take these two lines and put it here. I wonder if LeetCode has multi-line editing. Since they probably don't, I'm going to go take this. I ain't gonna retype stuff I already typed. You know what I mean? No retyping what's been typed. Never retype what has already been typed. Well, with that we get into problematic philosophy because someone has already typed this solution. If it's not the first time you've typed it, don't type it again. Only type one time. Programming philosophy right here. All right, this is what we want, right? Yep. Yep. All right. Let's run our test case. Passed. All right, here we go. We're going to submit this bad boy. So, I mean, our runtime is alright. Our memory is alright. I don't know what's causing so much memory. Like, we're not allocating anything here, right? I mean, I guess we're creating some pointers. I guess we're allocating 3 of these. I suppose we don't actually need to allocate temp here. We could reuse A or B. No, we don't want to. We could do that. Yeah, I don't know. I think, I'm not going to like sit here and try to figure out how to make this much faster because ultimately my goals have been achieved. I implemented a solution to problem 944 using SIMD. Mission accomplished. And it was a pretty long journey. I mean, I made several streams about this, so pretty proud of accomplishing this. Pretty proud of accomplishing this. Wait. Is this what we just submitted? How is this working? Wait, is this the code we just submitted? Huh. I'm surprised this is working because, like, doesn't seem like I would need this, right? I thought we got rid of this. Man, now I don't even know what's real. Like, huh. If I take this and add it back in. How does that work? How does that work? I forgot where we changed. Like, at one point I was like, oh, that doesn't loop over everything. It doesn't make sense. Something like that. So what is virtual count? Seven. Seven? But that doesn't make sense because $14. So in the first one, we're going to do 1 and 0. And then the second, we're going to do 2 and 1. How is this passing? All right. Pretty sure if I went over here. Pretty sure now we're going to fail. Yeah. The deuce? But if we go up here and we delete this, is the code have just all bad test cases? What? How is this code even? How is this code even running? How is this passing? The hell? I don't have a good way to put all that stuff back in. I would have to make... I don't feel like doing it. All right, well, just because we have to have it the right algorithm. That's so weird. This causes me to have no faith in this at all. Yeah, we don't want to do this. We have to process all the strings. This is not that. This is this. What is this? We should contribute a test case, eh? We should contribute that test case we just made. Let's add a test case. Let's take the time to make a test case. First, we're going to take all of this. Oops. We should contribute the test case and see if our code before fails. How do I do this? This is tedious. I should write something to do it, eh? Eh. I don't wanna... This is tedious. We'll be done in a second. This is the type of quality content you come here to see anyway. It is. I know it. I just know it in my heart. All right. Yes, that is me looking down at my keyboard. Okay, and then we're going to go back. We're going to add this wonkiness back in. We know this doesn't work, but we're going to add it back in. To see that this test case fails. Oh, wait, no, that test case doesn't fail. Oh, yes, it did fail. Good. So to fix it, we have to go here and get rid of these. Cool. All right, let's submit. Let's we found a test case that our initial submission failed. So let's submit a test case. I didn't know you could do debugging in here. All right. How do I submit it? Didn't we used to see a thing? For submitting a test case? Where did that go? Huh. Where did it go? Well, I guess we won't add a test case anymore. That's kind of weird. Oh wait, maybe it was under. Ha! Here we go. This. Wait, where'd it go? Is there a bug in their UI? Am I missing something here? I saw it and then it was gone. Ha! You just have to scroll down. Oh. You just have to scroll down. Contribute. What is my LeetCode username? Niner Delta? Wonder why they need all this. I wonder if what I should do is add the code that failed. Yeah. Like, I want to contribute I want to contribute a test case. In fact, I think what I'm going to do is I'm going to actually put in the code that failed, right? And then like I want to put in the thing. I want to submit it in the way that should fail so that they can see like this should fail. Like, where am I supposed to include the test case? Yeah, they shouldn't put it like this because like this whole thing makes no sense. All right, here we go. I'm gonna be like you're. gonna put like big bold. Submit. That's probably a waste of time. Hey, I'm pretty happy with this. This was a journey. It sounds like it's time to play some Fortnite at the conclusion of this journey. Time for Fortnite. Let's change up the stream. I'm gonna take a little break and come back. We'll play some Fortnite. Alright, what's going on here? We don't have any sound from the game. Should probably look at settings for that, right? That's where that is. It's like is that what we want? I had this working. Doesn't make supposed to be finding the Elgato. Nope. No. Let's see if I. There, I had this working the other day. If I output. How does this work? If I output here, right? That should work. Right? But it doesn't seem like it is. Well, maybe we can't play tonight. Because can't get. Or you guys just won't be able to hear the game. Then we won't get a copyright strike for the music in the game. I think it has something to do with the Elgato software. Yeah, that should be outputting audio there. What am I hearing? What am I hearing in the back? All right. Audio input HDMI. So it seems like my audio I should be getting audio from the capture card. Seems like I should be getting audio from the capture card. Yeah, I don't know. That's a bummer. I guess I have to figure out how to do this with like a cable instead of with the capture card. I didn't want to have to do that. What am I hearing right here, though? Is there background noise coming through? Is my sound gate not working? Well, this is not supposed to be a debug the stream. This is annoying. Alright, well, I guess since I can't figure out the audio, it's in the stream. That's sad. I'll have to figure out what's going on with that. Anyway, the lighting is really messed up now, too. Lots of things to figure out. Alright, well, this was cool. Gonna end it here. Bye.